Most organizations think their AI rollout failed because the model wasn't smart enough or because users don't know how to prompt. That's the comforting story. It's also wrong. In enterprises, AI fails because context is fragmented. Identity doesn't line up with permissions, work artifacts don't line up with decisions, and nobody can explain what the system is allowed to treat as evidence. This episode maps context as architecture, memory, state, learning, and control. Once you see that substrate, Copilot stops looking random and starts behaving exactly like the environment you built for it. The foundational misunderstanding: Copilot isn't the system. The foundational mistake is treating Microsoft 365 Copilot as the system. It isn't. Copilot is an interaction surface, a very expensive, very persuasive surface. But the real system is your tenant. The identity model, the permission graph, the document sprawl, the metadata discipline, the lifecycle policies, and the connectors you've allowed to exist with no consistent ownership. Copilot doesn't create order. It consumes whatever order you already have. And if what you have is entropy, Copilot operationalizes entropy at conversational speed. That distinction matters because leadership experiences Copilot as random. They ask for an answer and they get something that sounds plausible, sometimes accurate, sometimes irrelevant, occasionally dangerous. Then everyone debates whether the AI is ready or whether they need better prompts. Meanwhile, the underlying reality stays untouched. The organization is running a probabilistic decision engine on top of a messy evidence substrate. Here's the uncomfortable truth. Generative AI isn't deterministic. It doesn't execute a rule set. It generates a best fit response to the context window it's given, using patterns learned from training and whatever enterprise data retrieval supplied at runtime. When that retrieval brings back conflicting documents, outdated procedures, or half-permissioned fragments, the model doesn't refuse out of professional ethics. It blends, it averages, it fills gaps. That's not a bug, that's how the mechanism works. So when executives say, it feels like it makes things up, what they're noticing is the collision between deterministic intent and probabilistic generation. Enterprises are built on intent, approval chains, segregation of duties, policy statements, audit requirements. Copilot is built on likelihood, which next token best fits the prompt, plus the retrieved context. You can't manage that mismatch with training sessions and prompt libraries. You manage it by engineering the context substrate so the model's probability space collapses toward your actual truth. Most feature-led rollouts fail for a simple reason. They don't enforce design assumptions. Copilot gets deployed like a productivity feature, licenses assigned, a few champions trained, a dashboard watched. And none of the architecture that governs context gets corrected. SharePoint inheritance remains broken, sites remain overshared, sensitivity labels remain inconsistent, Teams chats remain the de facto system of record, a dozen final V7 documents remain authoritative because nobody has the political energy to delete them. Then Copilot gets blamed for being inconsistent when it's faithfully reflecting inconsistent context. This is why the Copilot is the strategy narrative collapses at scale. You can't scale a surface. You can only scale the system underneath it. And that system behaves like capital. Context is enterprise capital. It compounds. When context is structured, fresh, and permission correct, every workflow built on top of it gets cheaper, faster, and more reliable over time. Retrieval gets cleaner. Answers get grounded. Agents become viable because they can see state, evidence, and constraints without guessing. You stop paying people to relitigate decisions that already happened. That's compounding return. When context is sloppy, context also compounds, just in the other direction. You get context rot, you get permission drift, you get more duplicated sources of truth, you get more exceptions, entropy generators, because people can't find what they need, so they recreate it, and now Copilot amplifies the rot because it surfaces and recombines it. You've built an engine that accelerates your existing documentation debt into operational debt. If this sounds abstract, translate it into a simple system law. Copilot cannot be more reliable than the context boundary it operates inside. So the only responsible way to talk about high-performance autonomy is to stop asking whether Copilot is smart and start asking what substrate you've built for it to reason over. What does it treat as memory? What does it treat as current state? What does it treat as evidence? What does it treat as policy? And what does it do when those are missing? In other words, what is the underlying engine? Because once Copilot becomes the default interface for work, chat, documents, meetings, analytics, the tenant becomes an authorization and context compiler. It continuously decides what a given user at a given moment is allowed to see and which artifacts are eligible to influence the next answer or action. That's the real platform, not the UI. And if you don't deliberately design that platform, you still get one. You just get it by accident, assembled from years of drift, exceptions, and unchecked sharing. So the conversation shifts, not how do we prompt better? Instead, how do we architect context so the system can't plausibly be wrong? That's where this episode goes next, defining context like an architect would, so you can actually build it, govern it, and stop mistaking surface polish for system integrity. The context defined like an architect would. Context is one of those words that gets used like perfume. Everybody likes the idea. Nobody can measure it. And because nobody can measure it, nobody can govern it. So define it in architectural terms. Context is the minimal set of signals required to make a decision correctly under the organization's rules at a specific moment in time. Not all the data, not whatever the user pasted into chat, not everything the tenant can search. Minimal, required, correct, time-bound. That definition forces discipline because it immediately raises the real question: what signals count and who is accountable for their integrity? In this ecosystem, context is an engineered bundle. It's identity plus permissions plus relationships plus state plus evidence plus freshness. Remove any one of those and you don't get slightly worse answers. You get a different system. Identity means who is asking, in what role, under what device and session conditions. In Entra terms, that's not just a user object, it's the authentication event, the token, the conditional access posture, the group memberships that haven't drifted, and the entitlements that were supposed to expire but never did. Permissions means what that identity can actually see, and more importantly, what the system believes it can see. Because Copilot doesn't negotiate permissions, it inherits them. If your permission model is sloppy, the AI doesn't become helpful. It becomes an oversharing assistant with perfect confidence. Relationships means the graph of work, who works with whom, on what, and how recently. This is the piece enterprises keep ignoring. They treat relationships as nice-to-have personalization. In reality, relationships are relevance routing. They tell the system which documents are likely to matter, which meetings were decision points, and which people are authority sources. State means what is happening right now, not what happened last quarter, not what's in a PDF, not what someone promised in a Teams chat. Current ownership, current status, current exceptions. If state isn't explicit, the system will reconstruct it from artifacts, and it will reconstruct it badly. Evidence means the source is eligible to influence the output. A document isn't evidence just because it exists in SharePoint. Evidence has lineage, it has an owner, it has a version, it has a reason it should be trusted over the other 6 documents that say something similar but not identical. Freshness means the time boundary where truth expires. A policy written 2 years ago might still be binding, or it might be dead. A procedure from last month might be wrong because the tool changed last week. Without freshness, context becomes archaeology. Now draw the line that most organizations refuse to draw. Data is not context. Data is raw material. Context is curated, permission-correct, relationship-aware, time-valid material, assembled for a decision. If you feed raw data to an AI and call it context, you'll get outputs that sound plausible and fail audits. This is where context windows and relevance windows show up. The context window is the technical boundary, what the model can see in the prompt plus retrieved content. The relevance window is the governance boundary, what the system is allowed to consider for this decision. Those are not the same thing. You can technically retrieve 1,000 chunks of text. That does not mean 1,000 chunks are eligible. Bigger context is not better context. Bigger context is how you dilute signal, increase hallucination probability, and create the worst kind of failure. Answers that look grounded because they cite something, but the something is irrelevant or outdated. So measure context quality like an architect measures any substrate. Authority. Does this come from the system of record or from a random copy someone saved to their desktop and uploaded? Specificity. Is this the actual procedure for this business unit or a generic guideline that was never enforceable? Timeliness. Is this still true today in this tenant with today's controls? Permission correctness. Is the system allowed to use it for this user, for this purpose right now? And here's the subtle one, consistency. If 2 sources disagree, your system has a decision problem, not an AI problem. Either you define precedents or the model will average the conflict into something that never existed. Once context is defined this way, Copilot's behavior stops being mysterious. It becomes a deterministic response to a probabilistic input set. And if the input set is noisy, stale, or permission chaotic, you didn't deploy intelligence. You deployed a narrative generator attached to your org chart. This is also why agentic workflows break first. Agents don't just answer. They choose tools, take actions, and update state. That means their context isn't only what should I say. It's what is true, what is allowed, what is relevant, and what happens next if I'm wrong. If you don't engineer context with those constraints, autonomy doesn't emerge. It degrades, and it degrades fast. Why agents fail first. Non-determinism meets enterprise entropy. Agents fail first because they turn ambiguity into motion. A chat answer can be wrong and still get politely ignored. An agent can be wrong and still create tickets, send mail, change records, provision access, or escalate to the wrong person with the wrong evidence attached. The enterprise doesn't experience that as AI being fuzzy. It experiences it as operational damage with a natural language explanation. That's the difference between generation and autonomy. Non-determinism is tolerable when the system only talks. It becomes unacceptable when the system acts. And enterprise environments are engineered to produce ambiguity at scale. Not because people are careless, but because the platform rewards exceptions. Every time a team can't find the right policy, it writes a new one. Every time a workflow doesn't fit the tool, someone creates a side channel in Teams. Every time permissions are too strict, access gets broadened temporarily and never tightened. Over time, these pathways accumulate. Agents don't solve that. Agents amplify it. Here's what most people miss. Agents don't just need context to answer questions. They need context to choose the next step. Tool selection, scope selection, escalation selection, and stopping conditions. If any of those are underspecified, the agent will still move forward because its core function is completion. It optimizes for finish the task inside the constraints it can see. When the constraints are missing, it manufactures constraints out of whatever it retrieved. That's where entropy wins. In practical terms, the first failure mode is wrong tool choice. The agent sees 3 pathways: update a Dataverse record, send an email, or open a ServiceNow ticket through a connector. The tenant has no explicit policy that says incidents of type X must go to system Y and only after evidence Z is attached. So the agent picks the tool that looks semantically compatible with the prompt and the retrieved artifacts. That's not intelligence. That's pattern matching under incomplete specification. The second failure mode is wrong scope. This one is more dangerous because it looks like competence. The agent gets asked, clean up stale vendor records. It retrieves a procurement SOP that uses the word stale, but it doesn't define what stale means: last transaction date, contract end date, risk rating, or compliance status. So the agent applies an implicit definition. Then it acts across a data set larger than anyone expected because nothing in the context boundary told it where to stop. This is how you get irreversible work from reversible language. The third failure mode is wrong escalation. In a healthy enterprise, escalation is deterministic. Ownership is known, deputies are defined, and exceptions route to named roles. In most enterprises, escalation is social. Ask the person who usually knows. Graph relationships can help, but only if you let them. If you don't model ownership and decision rights, the agent escalates to whoever appears relevant, often the loudest signal, not the correct authority. And then there's the failure that governance teams hate most: hallucination-driven decisions. This is not the model inventing trivia. This is the system taking action based on plausible synthesis when evidence is incomplete. An agent can cite a policy that exists, apply it to a context where it doesn't, and generate a recommendation that looks audit-friendly because it contains words like per procedure and aligned to policy. Governance can't audit vibes. Auditors ask what evidence drove the decision, who approved it, and what controls prevented the wrong evidence from being used. If your agent's evidence is a blended summary of 5 half-related documents and a meeting transcript from last year, you don't have automation. You have a liability generator with a friendly tone. So the principle becomes blunt. Autonomy requires context discipline, not optimism. If a workflow cannot state its evidence standards, its scope boundaries, its stopping conditions, and its escalation rules, it is not ready for agents. Not because the agent is weak, because the enterprise hasn't defined the decision model the agent is supposed to obey. This is also why agent pilots look good in demos and fail in production. Demos are clean, the dataset is curated, the permission model is simplified, the workflow has an implied owner who happens to be in the room. Production is adversarial by default: stale docs, conflicting versions, inherited access, and people who will absolutely ask the agent to do something the policy never anticipated. Agents don't break because they're immature. They break because the enterprise context Substrate is. And that brings the conversation to the practical architecture question. If agents need disciplined context to act safely, where does that discipline live? What is the enterprise mechanism that turns scattered work into structured memory? That's the next layer. Graph as organizational memory, not plumbing. Graph as organizational memory, not plumbing. Most enterprises already own the hardest part of AI context, and they still manage to waste it. Microsoft Graph is not a set of APIs. It is not integration plumbing. Architecturally, it's the closest thing Microsoft 365 has to an organizational nervous system. A living map of people, artifacts, interactions, and the signals that connect them. That distinction matters because memory in an enterprise isn't where files live. Memory is how the organization refines the truth it already produced. Graph captures relationships that normal storage can't. Who met, what they referenced, who edited what, which thread a decision came from, which people consistently co-author, and which documents cluster around a project even when nobody bothered to name them well. It's relational intelligence, and relational intelligence is what makes retrieval feel like understanding instead of scavenger hunting. Most organizations treat retrieval like keyword search with better marketing. That's why Copilot feels random. The system can only retrieve what the organization made retrievable. And in a tenant with SharePoint sprawl, Teams as a shadow record system, and naming conventions that died in 2019, Keyword search becomes an archaeology exercise. Graph changes that, but only if you treat it as memory, not as a connector framework. Here's the simple version. Storage holds objects. Memory holds meaning. A document library is storage. It doesn't know why a file mattered, who trusted it, or which meeting made it binding. Graph, at least conceptually, can infer those things through connections, the meeting where it was discussed, the people who referenced it, the tasks that got created after it, the email thread that escalated because it contradicted another artifact. That's why Copilot consumes relational intelligence isn't a slogan. It's the actual dependency chain. When Copilot produces a summary that looks like it understands the politics of a decision, it's not psychic. It's using the tenant's relationship signals to decide what evidence is likely to matter to this user in this moment for this workstream. But enterprises rarely engineer that layer deliberately. They let it emerge accidentally from behavior, which means it inherits the same biases and gaps as the behavior. The loudest teams create the most artifacts. The most permissive sites generate the most accessible signals. The people who refuse to document decisions force the system to reconstruct them from fragments. The graph becomes a mirror of organizational habits, and mirrors aren't governance. So the question becomes, what does it mean to engineer graph as organizational memory? It means you stop treating graph as an output and start treating it as a design input. You decide which work products are authoritative and make them easy to identify. Not by telling people to be disciplined, but by structuring where decisions land. You decide which meetings are decision points and ensure transcripts and artifacts are stored in predictable locations with predictable access. You decide which conversations are ephemeral and which are records. And you create the conditions where the relational signals are high quality. Because graph doesn't create meaning, it indexes the trail your organization leaves. If the trail is incoherent, memory retrieval becomes probabilistic. If the trail is coherent, memory retrieval becomes repeatable. That's the entire autonomy game. This is also where organizational memory stops being a soft concept and becomes an operational one. In a high-performance enterprise, the system can answer what was decided, when, by whom, with what evidence, and what changed since then, not because someone wrote a perfect document, because the architecture made it easier to produce structured traces than to produce chaos. Now connect this back to agents. Agents don't just need the latest document. They need the work graph, the relationships that indicate which sources are binding, which are drafts, which are stale, and which are politically sensitive but operationally critical. They need to know the difference between a random file that matches a query and the file that drove the last 2 escalations and got referenced in the quarterly review. That's why graph as memory is the substrate for autonomy. But here's the catch. Memory is useless if it can't be trusted. And in Microsoft 365, trust collapses the moment permissions drift. If the system can retrieve the right artifact but expose it to the wrong identity, you don't have intelligence, you have automated disclosure. So the next layer is the one everyone postpones until it becomes a headline. Permissions are the context compiler. Permissions are the context compiler. Most organizations talk about permissions like they're a compliance chore, a checkbox, a quarterly attestation exercise that nobody believes in. In reality, permissions are the context compiler. They decide what evidence is even eligible to exist inside the AI's world for a given user and a given workflow. That means permissions don't just control access, they shape intelligence. They determine whether Copilot and agents operate on signal or noise, on truth or on accidental exposure. And Copilot doesn't fix your permissions, it industrializes them. This is the part executives miss when they ask, why did Copilot show me that? Copilot didn't show anything. It retrieved content the user could already access, then summarized it. The system followed the rules you already deployed. If those rules are wrong, the AI becomes a high-speed amplifier for a decade of casual sharing. Over-permissioning creates AI-powered oversharing. Under-permissioning creates AI mediocrity. And both look like Copilot quality issues, which is convenient because it lets the organization avoid the real discussion. The permission model is not an administrative detail. It's the boundary of what the organization is willing to let the system treat as truth for that identity. Here's the uncomfortable truth. Most tenants run on permission folklore. People assume SharePoint inheritance works the way they think it does. They assume private channel means private in all the ways that matter. They assume that the folder called HR has HR permissions. They assume that external sharing was turned off in the places where it should be. They assume the access review they did last year is still meaningful. Those assumptions decay. Always. Permissions drift because organizations drift. Reorganizations, role changes, projects that end but never get archived, guest accounts that outlive the vendor contract, and the classic entropy generator. Someone says, just add everyone for now, we'll fix it later. Later never arrives. It metastasizes into default. Now put Copilot on top of that. You've effectively built a natural language interface to your permission debt, not just search, synthesis, correlation. The system can stitch together artifacts that were never meant to be read side by side. A budget doc here, a strategy deck there, a meeting transcript that shouldn't have been accessible, and suddenly the user gets an answer that contains information the business never intended to be connected. Not because Copilot is malicious, because your permissions made it possible. This is why permission trimming is performance tuning, not just risk reduction. When you reduce overbroad access, you don't only shrink blast radius, you reduce retrieval noise, you improve groundedness, you make relevance easier because fewer irrelevant artifacts are even eligible to be retrieved in the first place. Less eligible context often produces better answers. That sounds backwards until you remember what the model is doing. It's trying to construct the best narrative from the evidence it can see. If you give it a landfill, you get landfill-adjacent output. If you give it a curated shelf, you get something closer to a decision-grade response. SharePoint sprawl is the classic failure pattern here. Sites proliferate faster than ownership models. Broken inheritance becomes a lifestyle. Everyone except permissions multiply. Sharing links become the real access model because it's easier than fixing groups. Teams creates artifacts across chats, channels, meeting recaps, and loop components, and the organization loses any coherent sense of what is authoritative and what is incidental. Every one of those exceptions is a new compilation pathway for context. That's what permissions are doing at scale, compiling a context boundary from a messy, distributed authorization graph. And if you don't intentionally constrain that compiler, it will compile chaos, reliably, at machine speed. This is also why least privilege isn't a moral stance, it's an autonomy prerequisite. Agents can't be trusted with broad, implicit access, because their failure mode isn't they looked at a file. Their failure mode is they incorporate that file into an action chain. They email, they update records, they generate decisions that get forwarded as if they were vetted. The permission model becomes the blast radius model for autonomous behavior. So if you want a high-performance autonomous enterprise, you treat permission architecture as a first-class design surface. Scoped access, explicit ownership, expiration, access reviews that actually revoke, and containers that reflect real work boundaries instead of historical accidents. And once you do that, something important happens. You stop conflating prompting with grounding, because prompts don't control what the system is allowed to know. Permissions do. And the next mistake leadership makes is spending a quarter training people to ask better questions, while the evidence pipeline stays polluted. So the next layer is the real separation, prompt engineering versus grounding architecture. Prompt engineering versus grounding architecture. Prompt engineering is the part everybody can see, so it gets all the attention. It's language, it's training, it's a worksheet with best prompts. It's the illusion that if people just ask nicely enough, the system will behave. And that's not how enterprise AI reliability gets built. A prompt is a request. Grounding is the evidence pipeline that decides what the system is allowed to treat as truth when it answers that request. Prompts operate at the interaction layer. Grounding operates at the substrate layer, and substrate always wins. Here's what most people miss. Prompt engineering tries to control the model. Grounding architecture tries to control the inputs. Only one of those scales. Prompts don't scale because people drift, workflows drift, vocabulary drifts, and the organization never agrees on one canonical way to ask for the same thing. One person says incident, another says outage, a third says service degradation, and someone in manufacturing says line down. The prompt library becomes a museum of last quarter's language. Grounding doesn't care what word you used. Grounding cares what evidence is eligible, what scope applies, and what the system should do when the evidence doesn't exist. That's the strategic distinction. So the question leadership should ask is not, are our users trained? It's, do we have grounding primitives? Grounding primitives are the repeatable mechanics that keep outputs bound to enterprise reality. Authoritative sources, scoped retrieval, freshness constraints, permission-correct access, provenance, and the harshest but most necessary behavior, citations or silence. Citations or silence means the system either shows where it got the claim or it refuses to claim. Not because refusal is polite, because refusal is the only honest output when the evidence substrate is incomplete. In an enterprise, sounds right is not a valid confidence level. This also forces a design decision you can't outsource to Copilot. Which sources are authoritative for which decisions? A procedure stored in a random team's file tab is not authoritative. A policy doc with no owner and no review date is not authoritative. A deck that says draft but is widely shared is not authoritative, even if it's socially influential. Grounding architecture requires the organization to declare precedence. System of record beats convenience, current version beats nostalgia, controlled container beats personal archive. Now, connect this back to Microsoft 365. Copilot can ground to tenant data, but it can't manufacture governance. It will pull what's accessible and relevant by its retrieval logic, and it will do its best. If you want something better than its best, you engineer the retrieval environment. That includes permission trimming, which you already established as a context compiler problem, but it also includes retrieval scoping, making sure the system doesn't search the whole tenant. when the decision only needs a specific project space, a specific knowledge base, or a specific business unit's procedures. A relevance window is not optional here. It's the cost control and risk control boundary for AI reasoning, because every extra chunk of context you let into the window isn't neutral. It's an entropy injection. It increases the chance the system will synthesize across conflicting artifacts, and it increases the chance it will cite something that is technically true and practically wrong. That's how you get polished nonsense. The other grounding boundary most organizations ignore is web grounding. When web grounding is enabled, part of the request can leave the tenant to perform a public search, then return results for synthesis. That is not enterprise knowledge. That is public internet retrieval mediated by Bing. Treat it like you would treat a user typing into a search engine. If you wouldn't type it into a public search box, you don't send it through web-grounded Copilot. That's not paranoia. That's architectural hygiene. Now, if you want one mental model that makes this simple, here it is. Prompting is steering a conversation. Grounding is constraining a decision engine. Steering fails when the road is missing. Constraints hold even when the driver improvises. So when an executive team asks why Copilot outputs vary, the honest answer is because you built a variable evidence substrate. The cure is not a better prompt. The cure is an engineered grounding architecture that makes the right evidence easy to retrieve and the wrong evidence ineligible. And once grounding is treated as architecture, you stop rewarding fluency. You reward traceability. You reward abstention when the system can't prove its work. And you start designing the next thing enterprises avoid, an explicit relevance model. Because grounding without scoping just becomes high-speed retrieval of the entire mess. That's why the next layer is relevance windows, the discipline nobody budgets for. Relevance windows, the discipline nobody budgets for. Relevance windows are where most Copilot and agent strategies quietly die, because a relevance window forces the enterprise to answer an uncomfortable question: what information is allowed to influence this decision, and what information is explicitly disallowed, even if it's technically available. That distinction matters. The context window is what the model can ingest. The relevance window is what the organization authorizes as decision-grade evidence. If you don't define a relevance window, the system defaults to whatever retrieval can find. And retrieval, left alone, optimizes for match, not meaning, not precedence, not safety. So the simple definition is this. A relevance window is the bounded set of evidence eligible for a specific workflow at a specific step under a specific policy posture. It's scoping, but with intent. That means you're not just saying, search this site. You're saying, for this decision, only these sources count, only these versions count, and only within this time horizon. Now, the part everyone gets wrong, they assume more context increases accuracy. It doesn't, not in enterprise work. More context increases surface area, more contradictions, more stale procedures, more almost right artifacts that pull the model into a blended answer that never existed. If you want dependable outputs, you don't widen the window. You tighten it until the remaining evidence is both relevant and authoritative. This is also where freshness becomes non-negotiable. A relevance window without freshness is just a curated archive, and archives are where outdated truth goes to look official. Enterprises love that, auditors don't. Freshness is the policy that says this evidence expires, not because it's old, but because the organization changes faster than documents get revised. Processes get updated, tools get renamed, regulatory obligations shift, the people who own the procedure leave, and the document stays forever. That's context rot. And context rot is worse than missing context because it produces confident wrongness with citations. So you need explicit freshness rules, review dates that actually mean something, versioning that preserves lineage, and deprecation behaviors that make old artifacts ineligible by default. Not hidden, ineligible. Then you hit the next reality. Versioning isn't a document problem, it's a decision problem. Enterprises routinely keep multiple truths alive because nobody wants to pick the winner. Drafts get socially adopted. A slide deck becomes policy because it was presented to leadership once. A team's message becomes procedure because it got pinned. And now you have an evidence conflict that the AI will resolve the only way it can, by synthesizing. But synthesis isn't governance, it's compromise. So relevance windows require precedence rules. When two sources disagree, the system needs a deterministic hierarchy. System of record beats guidance, signed policy beats draft, controlled repository beats personal stash, most recently reviewed beats, I think this is still right. If you don't encode precedence, you're outsourcing policy arbitration to a probabilistic model. That's not innovation. That's negligence with better UX. Now connect this to executive outcomes because that's the only language that changes budgets. A disciplined relevance window reduces rework. It shortens review loops. It prevents looks plausible decisions from entering governance processes and wasting everybody's time. It also reduces risk. Fewer accidental disclosures, fewer policy contradictions, fewer decisions made on dead procedures. And it makes autonomy possible because agents can't operate safely on infinite evidence. They need a bounded arena where the next action is derived from eligible truth, not from whatever the retrieval system dredged up. Here's the practical test. If the organization can't say for workflow X, the eligible evidence is A, B, and C, and everything else is advisory at best, then the workflow is not ready for agentic execution. It's barely ready for conversational advice. This is also why nobody budgets for it. Relevance windows aren't a license line item. They are design work. They force content owners, security, compliance, and platform teams into the same room to agree on what counts. And that agreement exposes every hidden inconsistency the organization has been living with, which is exactly why it's valuable. Because once you define relevance windows, you can finally do something enterprises claim they want: reduce noise without reducing capability. You can make Copilot and agents smarter by making their world smaller and cleaner. And you can make refusal a feature, not a failure. If the evidence isn't in the relevance window, the system escalates instead of guessing. That's the discipline. And it's the bridge from good chat to safe execution. But relevance windows only solve evidence eligibility. They don't solve the next thing that makes work real: state. Because even if the system knows what evidence counts, it still needs to know what's happening right now, who owns it, and what step comes next. That's where the architecture moves next, from memory and evidence into operational memory, where state lives and autonomy stops looping. Dataverse as operational memory. Graph gives you organizational memory, what work meant, who was involved, and which artifacts clustered around decisions. But memory alone doesn't run a business. Work becomes real when it has state. State is the part nobody can search their way into. It's the current truth of a workflow: what step it's in, who owns it, what's blocked, what exception was granted, and what the system is waiting on. If that truth only exists in human heads and scattered Teams messages, you don't have a workflow. You have a rumor with attachments. This is where Dataverse earns its place. Not as Power Platform storage, not as tables for citizen devs. Architecturally, Dataverse is operational memory, a governed place to record what is happening now, in a form that automation and agents can't misinterpret. Because an agent without state becomes a loop generator. It re-asks questions you already answered. It resends approval requests because it can't confirm they were completed. It reopens issues because it can't see closure criteria. It escalates prematurely because it can't distinguish waiting from stuck. And then leadership calls it immature, when the actual problem is that the enterprise never gave the system an authoritative place to store reality. Operational memory fixes that by making intent explicit. In Dataverse terms, that means you don't just store records, you store the decision model, entities that represent the work itself, not just the data around it. You define a case, an approval, an exception, a control attestation, a vendor onboarding, an incident review. Whatever the workflow is, the entity becomes the contract between humans, tools, and agents, and the contract has to contain certain fields, whether people like it or not. Ownership: who is accountable right now, and who is the escalation path if they're unavailable. Status: not a vague in progress, but a state machine that reflects real gates. Drafted, submitted, pending approval, approved, executed, verified, closed. SLA and deadlines, so the system can differentiate urgent from normal without emotional language. Scope boundaries: what the agent is allowed to change and what it must only recommend. Exception tracking, because exceptions always happen, and if you don't record them, you can't govern drift. This is the point where autonomy stops being a Copilot conversation and becomes a control plane conversation. If Dataverse holds state, then agents can operate as stateful actors, read the current step, retrieve only the evidence relevant to that step, take a bounded action, update the state, and log what happened. Without that, you get the enterprise version of Groundhog Day. Here's the counterintuitive part. State reduces hallucinations without touching the model, because many hallucinations in enterprise work aren't the model inventing facts. They're the model improvising missing workflow reality. If you ask, has procurement approved this vendor? And the system can't see an approval state, it will infer from the most recent email thread or a meeting recap or a spreadsheet someone updated last week. That's not reasoning, that's guessing with citations. If Dataverse contains the approval record, the question becomes deterministic. The agent doesn't need to be smart, it needs to be obedient. This is also why Dataverse is the right place to encode refusal conditions. An agent should not guess whether a change is authorized. It should check whether the approval entity exists, whether the right role approved it, whether the approval is still valid, and whether the conditions match. If any of those fail, the agent escalates, not because it's cautious, because it's operating inside an engineered boundary. And yes, that boundary is annoying to build, because it forces the organization to define what it pretends is already defined. Who owns this? What does done mean? What's the SLA? What counts as an exception? Which steps are reversible and which are irreversible? But once you define it, something else happens. You stop treating Teams and email as state storage. They go back to being communication layers. Useful, human, and fundamentally unfit to act as a system of record. Dataverse becomes the place where the workflow's truth lives, while Graph becomes the place where the workflow's context and supporting evidence can be retrieved. That split matters. Memory tells you what happened, state tells you what is happening, and autonomy requires both. Because the moment an agent can read state, it can stop relitigating, it can stop re-asking, it can stop re-summarizing the same thread like it's new information. It can progress work. And if you want the enterprise version of high performance, that's it. Fewer loops, fewer duplicate efforts, fewer approvals that happen twice because nobody could prove the first one happened. Operational memory isn't glamorous. It's also the difference between a demo agent and a production system. Fabric as analytical memory. Dataverse gives the system operational memory, the live state of work. But operational memory alone doesn't improve the enterprise. It only stabilizes it. Stability is not learning. Learning requires a different kind of memory, analytical memory. The enterprise needs to remember patterns, not just status. It needs to know what keeps breaking, where time gets wasted, which approvals are pure theater, and which exceptions are actually permanent workflow branches pretending to be temporary. That's where Fabric fits, not as the place you run reports. Architecturally, Fabric is the learning layer, the part of the autonomy stack that turns accumulated execution into improved design. Here's the simple version. Graph tells you how work connects. Dataverse tells you what work is happening. Fabric tells you why work keeps failing. And if you don't build that layer, you're stuck in a loop where the organization keeps automating yesterday's dysfunction with higher speed and better phrasing. Analytical memory starts with aggregation, not dashboards. Aggregation of signals that were previously invisible because they lived in too many places. Case cycle times, handoff delays, reopened incidents, repeated escalations, approval latency by role, exception frequency by workflow step, and the quiet killer, rework triggered by missing or conflicting evidence. Most enterprises can't answer basic questions like which teams create the most exceptions and are those exceptions correlated with missing permissions, missing templates, or missing ownership. They can't answer because the raw events exist, but the system never turned them into a governed, queryable narrative. Fabric is how that narrative becomes evidence. Now, a warning, analytics is where enterprises lie to themselves with math. Correlation is not causation. That distinction matters. If Fabric shows that incidents take longer when a certain team is involved, the lazy conclusion is that team is slow. The real cause might be that the team gets the hardest incidents, or that the routing logic dumps chaos on them, or that the upstream context is incomplete, so they spend the first 6 hours reconstructing what should have been handed to them. So the guardrail for analytical memory is this. Treat analytics as hypothesis generation, not automatic policy enforcement. Fabric should inform better orchestration rules, but it should not auto-legislate them without validation. Otherwise, you're automating false narratives. And false narratives are how organizations turn temporary anomalies into permanent bureaucracy. When Fabric is used correctly, it closes the loop. It turns operational history into design pressure. For example, if the system sees that a workflow step consistently stalls because approvals come from a role that isn't staffed after hours, that's not a people problem. That's a state model problem. The escalation path is wrong. The authority model is incomplete. The workflow needs an alternate lane with a defined supervisor, or it needs time-bound delegation that expires, or it needs a different gating mechanism entirely. That's learning, not a chart. Or consider relevance windows. You can define them, but without telemetry, you won't know if they're working. Fabric can show you how often an agent needed to escalate because evidence was missing, which sources were used most often, which sources were frequently retrieved but never cited, and where retrieval produced conflicting guidance. That's not just usage data, that's feedback about your context substrate, and it's feedback you can act on. This is where autonomy stops being a product purchase and becomes an operating model. Because an autonomous enterprise is not one where the agent does more things. It's one where the system becomes better at deciding what it should do over time with fewer human interventions. That means analytics must change orchestration rules, not just inform quarterly reviews. If Fabric shows that certain exception types always lead to the same remediation steps, then you can codify a lane, auto-handle within defined boundaries, log evidence, update Dataverse state, and only escalate when the pattern breaks. If Fabric shows that a particular policy source is constantly contradicted by newer procedures, that's not an AI problem. That's content governance drift. The fix is to deprecate the policy or reissue it or mark it as advisory and make the precedents explicit. Fabric becomes the place where drift is visible. And drift is the true enemy of autonomy, because the moment the environment changes faster than the context substrate updates, the agent becomes a historical reenactment tool. It will keep operating on what used to be true with perfect confidence and fully logged explanations. Analytical memory is how you prevent that. It's how you detect where the system's behavior is diverging from intent, rising exception rates, growing retry loops, increasing time to decision, widening variance between teams, and changes in what evidence gets cited. Then you feed those insights back into the control plane, update the relevance windows, tighten permissions, change routing rules, revise the state machine, or adjust refusal thresholds. That feedback loop is the difference between we deployed Copilot and we built an enterprise that learns. And once you see Fabric this way, the autonomy stack becomes obvious. Memory, state, learning, interaction. Each layer compensates for a failure mode in the others. Each layer produces signals the next layer depends on. Remove the learning layer and you don't get autonomy. You get automation that rots in place. The autonomy stack. Memory, state, learning, interaction. Now the stack is visible and it's embarrassingly simple. Not easy, simple. Autonomy in Microsoft 365 isn't a feature you toggle on. It's an emergent property of 4 layers that either align or they fight each other until the whole thing feels random. Memory, state, learning, interaction. And the order matters because each layer is compensating for a specific kind of enterprise failure. Memory is graph, not because graph is magical, but because it encodes relationships, who, what, when, and the trail of work signals that makes retrieval feel like recall instead of search. Graph is how the system learns what a piece of work meant inside the organization. Without that, Copilot has to treat every request like it's happening in a vacuum. You get generic answers, generic summaries, and the same, could you provide more context, loop that wastes executive time. State is Dataverse. It's operational truth. What step the workflow is in right now, who owns it, what is blocked, what was approved, what exception was granted, and what the system must not do without supervision. Without state, agents become polite but unreliable interns. They ask again, they re-summarize, they reopen, they can't tell whether progress happened, so they manufacture progress by talking about progress. Learning is fabric. It's the layer that converts a pile of completed workflows into patterns, where approvals stall, where evidence is missing, where exceptions cluster, where retries spike, where policies contradict reality. Without learning, the organization never gets better. It just runs the same broken process faster, then celebrates adoption, while operational drag quietly remains. Interaction is Copilot, chat, embedded assistants in Office apps, Teams, and whatever agent front-end leadership is currently excited about. Interaction is where humans meet the system. It's also the only layer people see, which is why it gets blamed for everything. But interaction is downstream. It cannot fix memory, state, or learning. It can only expose their quality. This is the foundational reframe. Copilot is not intelligence. Copilot is presentation. And autonomy isn't agents. Autonomy is what happens when the presentation layer is backed by memory, anchored in state, and corrected by learning. Here's the system behavior when a layer is missing. If you have interaction without memory, you get fluent output with no organizational awareness. It reads like a smart public chatbot, helpful but detached. That's where leaders conclude, it doesn't understand our business. If you have memory without state, you get good recall but no execution. The system can tell you what happened in meetings, who said what, and which documents were involved, but it can't move the workflow forward reliably. It becomes a historian, not an operator. If you have state without memory, you get deterministic workflow automation with no situational intelligence. It can progress cases and route approvals, but it can't explain why something is blocked or which evidence is missing because it doesn't understand the surrounding work graph. It becomes a ticketing system with better branding. If you have learning without control, you get dashboards that describe failure beautifully while nothing changes. The system knows where entropy lives, but it can't enforce corrections, so the drift continues. And if you try to skip straight to agent features without the stack, you'll see the predictable symptoms: generic answers, repeated loops, policy violations, and the worst one, high-confidence outputs built on low-integrity evidence. So autonomy is alignment, not capability. That alignment depends on a concept most enterprises refuse to formalize: the context boundary. Every workflow needs an explicit boundary that says, this is the evidence we will consider, this is the state we will trust, these are the tools we will allow, and these are the conditions where the system must refuse to guess. Refusal is not a safety feature you bolt on later. Refusal is a design requirement for any system that will act, because probabilistic systems will always produce an answer. They are optimized to complete. If you don't engineer stop conditions, you're building a machine that will generate plausible motion even when it's blind. So the autonomy stack isn't a maturity model, it's a structural dependency chain. Graph provides memory, so retrieval has meaning. Dataverse provides state, so action has continuity. Fabric provides learning, so the system improves instead of drifting. Copilot provides interaction, so humans can steer, approve, and supervise. Get those 4 layers aligned, and the enterprise stops chasing smarter AI. It starts building evidence-bound decisions at scale. And that is the only definition of autonomy that survives contact with audit, security, and reality. Conceptual flow pattern, event, reasoning, orchestration. Once the autonomy stack is clear, the next question is operational. What does a context-aware system actually do, end-to-end, when work happens? Not in a demo, in a tenant, under drift, under load, with imperfect humans. The cleanest mental model is a 3-stage flow you can replay in your head: event, reasoning, orchestration. This is not how Microsoft built it. It's how you should design it, because it forces you to separate signals from decisions and decisions from actions. That separation is where control lives. Start with event. An event is a trigger that something changed in the work graph. An email arrives with a request, a meeting ends and produces a transcript, a document changes state from draft to approved, a ticket is created, a customer escalates, a procurement request hits a threshold, a user gets added to a sensitive group. The specifics don't matter. The pattern does. Events are cheap. Enterprises generate infinite events. The mistake is treating every event as a reason to ask Copilot. That turns autonomy into 1,000 micro-interruptions, and it guarantees noise-driven automation. So, architecturally, the event stage is where you normalize and filter. What type of event is this? What workflow does it belong to? And what context boundary applies? If you can't classify the event, you don't have autonomy. You have a chatbot waiting for attention. Then comes reasoning. Reasoning is where context becomes eligible evidence. This is the stage that decides what the system is allowed to consider, what it should ignore, and what it must verify before it acts. It's also where most agent failures actually occur, because people assume reasoning is just the LLM thinking harder. It isn't. Reasoning is a pipeline: retrieve, scope, score, and check. Retrieve means pulling candidate evidence from memory and state, graph relationships, relevant documents, recent meetings, and the Dataverse record that tells you where the workflow is right now. If the system can't find state, it has to guess, and you already know how that ends. Scope means applying the relevance window. Only sources X and Y count for this step, only within time horizon Z, and only under the identity posture of the requester. This is where permissions and sensitivity labels stop being compliance theater and become execution constraints. Score means ranking evidence by authority and freshness, not by semantic similarity alone. Similarity retrieves drafts and duplicates. Authority retrieves decisions. That distinction matters. Check means policy validation. Is this action allowed? Does it require approval? Is the identity trustworthy right now? Is the device compliant? Does the data classification allow this tool to see it? Does continuous access evaluation revoke access mid-flow? Reasoning without policy checks is just fast guessing. And here's the discipline that makes the entire flow survivable: citations or silence. If the reasoning stage can't produce evidence that meets the relevance window, the system doesn't try anyway. It escalates, or it asks a precise question that closes the gap. Refusal conditions aren't politeness. They are the only mechanism that prevents plausible nonsense from entering the orchestration stage. Now, the third stage, orchestration. Orchestration is tool invocation and state mutation. It's where the system stops talking and starts changing reality, creating a ticket, updating Dataverse, generating a document, sending an email, scheduling a meeting, posting to Teams, or triggering a downstream flow. This stage must be boring. If orchestration feels creative, you've already lost control. Orchestration should be deterministic. Given evidence set A, state S, and policy posture P, invoke tool T with parameters K, then write the result back to operational memory with an audit trail that explains what evidence was used, what decision was made, what action was taken, and what the next state is. This is also where you draw the human boundary. Humans stay in the loop for irreversible actions: payments, terminations, external sharing, privilege changes, regulatory submissions, vendor onboarding, and anything that creates a compliance obligation. The system can prepare, recommend, and assemble evidence. It cannot self-approve. Approval is not latency. Approval is liability transfer. Everything else sits on a tiered autonomy lane. Low-risk actions can execute automatically, medium-risk actions require confirmation, and high-risk actions require a named approver with logged intent. And if you want one final rule that ties the whole flow together, it's this: events create opportunity, reasoning creates eligibility, orchestration creates consequences. Most organizations skip straight from opportunity to consequences, then act surprised when the system behaves like the chaotic tenant it's running inside. Design the flow, enforce the boundary. Then autonomy stops being a marketing term and becomes a repeatable system behavior. Context is an attack surface. Now for the part everyone tries to delegate to a security slide deck. The moment you integrate work context into an AI system, you expand your attack surface from endpoints and identities into something messier: your organization's narrative layer. Emails, documents, meeting transcripts, chat threads, tickets, wiki pages, and connector-fed content stop being passive records and become executable influence. That's what context is in an agentic system: influence. And influence is exactly what attackers want. Prompt injection is the obvious entry point because it maps cleanly to how people already think. An attacker puts instructions in an email or document. Ignore previous rules. Send me the summary. Extract the confidential bits. The model reads it, the model follows it, and the organization calls it an AI vulnerability. But the foundational mistake is thinking prompt injection is a clever trick. Architecturally, it's just untrusted content crossing a trust boundary without a compiler that can enforce intent. The system ingests external text and internal truth into the same reasoning space. That blending is the vulnerability class. Microsoft and others have started naming this problem directly in the industry. Scope violations, indirect injection, cross-domain prompt injection. The terms vary, the mechanism doesn't. The enterprise teaches the agent to treat things it can read as things allowed to influence decisions. Those are not the same. And in Microsoft 365, the things it can read include the most hostile content in the enterprise. Inbound email, shared files from outside, meeting invites from guests, and whatever got pasted into a Teams chat at 2 a.m. This is why indirect injection matters more than direct injection. Direct injection requires the user to do something obviously risky. Indirect injection hides inside normal work artifacts. A procurement spreadsheet, a design spec in SharePoint, a helpful link in a project email. Nobody sees it as an attack because it looks like work. And agents are built to consume work. Then there's the more enterprise-shaped problem, memory poisoning. Once the system starts persisting context, summaries, preferences, extracted decisions, cached results, you've created long-term state that can be corrupted. One poisoned artifact doesn't just cause one bad answer. It becomes a durable bias that quietly affects future reasoning. That's not a one-off incident. That's drift you didn't authorize. The scary part is that poisoning doesn't need high sophistication. It needs persistence. If the system stores, "This vendor is trusted because it saw that phrase in a manipulated email thread," you now have a policy exception embedded in machine memory, an entropy generator with a timestamp. And because the output still sounds reasonable, the human supervisor may never notice. They just experience the system as oddly confident about certain decisions. Now, at the enterprise reality, context sources mix trust levels constantly. A single Copilot response might blend internal policy, a meeting transcript, a forwarded email from outside, and a web result if web grounding is enabled. If the system doesn't enforce provenance boundaries, trusted versus untrusted, internal versus external, authoritative versus advisory, then it will happily treat a hostile artifact as equal weight evidence. That is the zero-click conceptual threat, not necessarily that the user clicked nothing, but that the user didn't consent to importing hostile instructions into the reasoning space. The act of retrieval itself becomes the exploitation path. An email arrives, it becomes retrievable. Later, the user asks an unrelated question. Retrieval pulls the email because it matches. The payload activates because the model can't distinguish content to summarize from instructions to obey. That's how a normal tenant becomes an adversarial environment by default. And notice what this does to your earlier autonomy flow. Event happens. Reasoning retrieves. Orchestration acts. Attackers don't need to break encryption. They need to shape retrieval. So the defensive principle becomes blunt. Treat every context source as hostile until proven otherwise. Not external sources, every source. Because internal sources are hostile too, just accidentally. Outdated procedures, copied policies, contradictory decks, orphaned SharePoint sites, and meeting transcripts full of speculation. Hostile doesn't only mean malicious, it means unfit to drive decisions without validation. This is where security and architecture finally stop pretending they're separate disciplines. Context integration expands the blast radius of permission mistakes, content hygiene failures, and governance drift. And it does it with the worst possible UX. Fluent answers that look like competence. So if your autonomy strategy doesn't include provenance, isolation, and refusal conditions, it isn't an autonomy strategy. It's a high-speed social engineering surface that happens to run inside your tenant. Guardrails that actually hold. Least privilege, CAE, provenance. So if context is an attack surface, guardrails can't be guidance. They have to be mechanics, things the system enforces even when users are tired, rushed, or curious, and even when an attacker is deliberately shaping the narrative layer to get the agent to misbehave. 3 guardrails actually hold in Microsoft 365 because they're structural, least privilege, continuous access evaluation, and provenance. Least privilege is not a compliance slogan. It's the only way to keep autonomy from turning small mistakes into tenant-wide incidents. The common enterprise failure is granting broad access because it's operationally convenient. Files, read all, sites read all, wide SharePoint membership, or that classic move where one security group becomes the default audience for everything because nobody wants to manage boundaries. Then Copilot arrives, then agents arrive, and suddenly broad access isn't just broad access. It's broad retrieval plus synthesis plus action. That's the difference. When an agent can read widely, it can also act widely because tool invocation chains across whatever it can see. So least privilege has 2 benefits at the same time. It shrinks blast radius and it improves relevance. Fewer eligible artifacts means less noise for retrieval, less accidental contradiction, and fewer opportunities for an injected document to get pulled into the reasoning space. But least privilege also has a second requirement that people avoid. You need explicit tool gating. It's not enough to say the agent has read-only access. If the agent can call a connector that can send mail, create sharing links, update Dataverse, or open tickets, then read access becomes write impact through indirection. So the design law is simple. Separate read scopes from action scopes and keep action scopes narrow, time-bound, and workflow-specific. That's where Entra becomes more than sign-in. It's where identity starts behaving like a control plane for agentic systems. Scoped permissions, conditional access, and lifecycle governance for the non-human identities you're about to create. Service principles, managed identities, agent identities, whatever your architecture calls them. Then comes continuous access evaluation, and this is the one most architects underuse because it sounds like an auth detail. CAE is operational hygiene for autonomy. In a static system, you can tolerate the gap between access was valid and access should no longer be valid. In an agentic system, that gap becomes an exploitation window. If a user gets disabled, if a session is marked risky, if a conditional access policy changes, or if device compliance fails, you need access to collapse immediately, not at token expiry. That's what CAE is doing. It turns revocation into a runtime control, and it changes the architecture of your agent execution. Your agent has to handle claims challenges. It has to expect that a long-running task can lose authority mid-flight. It has to fail closed, not fail forward. No caching because it worked 5 minutes ago. No background retrieves that keep pushing until the platform relents. If the identity posture changes, the agent stops, records state, and escalates, because autonomy without real-time revocation is just deferred breach response. Now provenance. Provenance is the guardrail that makes audits possible and makes incident response not feel like archaeology. Provenance means the system can show what sources influenced the output, which ones were authoritative versus advisory, what was retrieved but rejected, and which policy checks allowed the action to proceed. Not a poetic summary of, I looked at several documents, an evidence trail. This is how citations or silence evolves from an answer quality tactic into a governance control. If the system can't name its sources, it can't be trusted to act. If it can name its sources but can't classify them, internal versus external, labeled versus unlabeled, current versus stale, then you still can't trust it because you can't tell whether it respected the boundary. Provenance also enables something leadership always asks for and rarely funds: rollback. If an agent took an action chain based on poisoned context, you need to know which records it touched, which tools it invoked, and which evidence it relied on, so you can unwind the change and quarantine the source. That's not nice to have. That's the minimum requirement for letting a probabilistic system mutate enterprise state. So the combined guardrail model is blunt. Least privilege defines what the system is allowed to see and do. CAE defines when that permission evaporates in real time. Provenance proves what actually happened, so you can govern drift and recover from failure. Everything else is suggestion. And suggestion is how context attacks become headlines. Drift, the slow decay of intent. Drift is the part of enterprise AI that nobody demos because it doesn't fail loudly. It fails politely, week by week, decision by decision, until the output still sounds competent but no longer matches intent. That distinction matters because drift isn't the model getting worse. Drift is the system environment moving while your assumptions stay frozen. And in Microsoft 365, the environment moves constantly. Teams reorganize, owners change, sites sprawl, labels get applied inconsistently, policies get rewritten, and the people who knew why a control existed leave. The tenant keeps working. The governance story doesn't. This is why it worked in the pilot is meaningless. Pilots run on handheld context, curated sites, known participants, clean permissions, and a small slice of organizational reality. Production runs on entropy. Production is where every undocumented exception shows up, and where every temporary workaround becomes permanent. Drift comes in multiple flavors, and the dangerous part is that they compound. Context drift is the obvious one. The sources the system retrieves become stale, duplicated, or contradictory. The procedure got updated, but the old version still ranks higher because it has more engagement. The final deck is buried under 3 drafts that got shared more widely. The decision happened in a meeting, but the meeting artifact got stored somewhere random, so the system reconstructs it from email fragments. Policy drift is subtler. Conditional access evolves. Data loss prevention rules get exceptions. External sharing gets loosened for a project, then never tightened. Sensitivity labels get introduced. Then half the organization ignores them because nobody enforced defaults. Eventually, the same question asked by 2 users yields different results because the policy substrate is no longer coherent. Naming drift sounds petty until it breaks retrieval. Teams rename projects, channels get repurposed, acronyms change. Incident becomes major incident, becomes service interruption because someone wanted better optics. Retrieval and relevance windows depend on stable vocabulary, but enterprises treat vocabulary like personal expression. Ownership drift is the one that kills governance. Sites have owners in theory and abandoned permissions in reality. Dataverse tables exist, but no one owns the state model as a contract. Fabric reports exist, but no one owns the feedback loop that turns analytics into policy changes. So the system accumulates intelligence, but nobody has authority to act on it. This is why output checking doesn't work as a drift strategy. Enterprises keep trying to govern by sampling outputs, review a few Copilot responses, spot check a few agent runs, and declare it acceptable. That's governance theater. Drift doesn't show up consistently in outputs. It shows up in behavior, what the system retrieved, what it ignored, what it attempted to do, how often it escalated, how often it retried, and where it wrote it work. Behavioral evaluation is the only thing that scales. You measure the system like you would measure a distributed service. Exception rates, time to resolution, escalation frequency, evidence coverage, tool invocation patterns, and permission faults. Not did it sound right, but did it act within the context boundary we designed? Now, the uncomfortable truth. Drift accelerates when you treat prompts, policies, and connectors as informal artifacts. If you don't version them, you can't control change. If you can't control change, you can't roll back. And if you can't roll back, every improvement becomes a one-way door. So versioning becomes a first-class capability. Prompts, grounding rules, relevance windows, connector configurations, and orchestration policies need explicit versions with owners, with change logs, and with rollback paths. Not because it's elegant, because the alternative is debugging a living system with no memory of who changed what. This is also where audit stops being a compliance exercise and becomes a drift detector. If you can trace which sources influence decisions over time, you can see when the system starts leaning on different evidence. If you can trace which identities accessed which context, you can see when permissions drift expands eligibility. If you can trace which workflows generate the most exceptions, you can see where state models no longer match reality. And once you can see drift, you can govern it. Not by freezing the system, but by accepting that autonomy is entropy management. You don't eliminate drift, you detect it early, constrain its blast radius, and correct it with controlled changes. Because in an autonomous enterprise, the most dangerous system is not the one that fails. It's the one that keeps working while it slowly stops obeying you. Context governance, turning trust into an operating model. Drift is inevitable. That's not pessimism. That's how tenants behave once they scale past a few disciplined teams and a few passionate owners. So the only serious question is whether the organization governs context like an operating model or whether it governs it like a project, a burst of effort, a set of slides, and a slow slide back into entropy. Context governance is not a committee that reviews AI outputs. It is the set of enforcement mechanisms that keep your context substrate trustworthy over time. Freshness, permission correctness, provenance, drift detection, and escalation. When the system encounters ambiguity, it is not allowed to solve with creativity. The first move is to stop treating context as a single thing. Governance has to map to the same layer boundaries you're building. If you can't name the owners of memory, state, learning, and interaction, you don't have governance. You have vibes plus an admin portal. So governance starts with ownership. Graph memory needs an owner model that is accountable for content, container hygiene, lifecycle policies, and what authoritative means in each domain. Not at a global level. At the workflow level, who owns the incident knowledge base? Who owns the procurement procedure library? Who owns the HR policy corpus? If the answer is everyone, then the system is ownerless. That means it will rot. Dataverse state needs a product owner, because state is a contract. Somebody has to own the entity model, the status transitions, the refusal conditions, and the approval gates. If the state machine can change without review, you've just created a silent bypass for autonomy. Fabric learning needs an owner that is responsible for closing loops, turning analytics into updated relevance windows, routing rules, and exception handling. If Fabric only produces dashboards, it's not a learning layer, it's a reporting cost. And Copilot interaction needs an owner who is responsible for the human boundary. What the system can do automatically, what requires confirmation, what requires approval, and what must be blocked by design. This is where AI policy becomes real, because it becomes enforceable behaviors, not training posters. Now, once ownership exists, governance becomes a set of lanes. You define tiered autonomy lanes that match risk, not ambition. A low-risk lane is where the system can draft, summarize, classify, and route, with auditable logs and no irreversible actions. A medium-risk lane is where the system can execute bounded actions, create tickets, update known fields, notify stakeholders under explicit scoping and rollback capability. A high-risk lane is where the system can only recommend, assemble evidence, and escalate to a named approver. This matters because autonomous enterprise does not mean everything automated. It means automation is proportional to liability. Then you define evidence standards because trust isn't a feeling, it's a rule set. For certain workflows, the system must cite sources or abstain. For others, it can act on state alone because the state is the source of truth. For still others, it can only proceed if evidence is both authoritative and fresh, reviewed within a declared window, labeled correctly, and retrieved from the governed container. And you make that standard explicit. When the system cannot meet the standard, it refuses and escalates, not because it's safe, because it is controlled. The next piece is drift detection as a continuous control. You don't wait for a quarterly review to discover that permission sprawl expanded eligibility or that your relevance window quietly widened because new content sources appeared. You instrument it, permission fault rates, exception rates, escalation frequency, evidence coverage, and provenance gaps. Those aren't AI metrics. Those are context integrity metrics. And the final piece is the escalation model, because governance without escalation is just documentation. Escalation needs named paths. Who gets notified when a workflow hits missing evidence, conflicting evidence, or policy violations. And escalation needs time. If nobody responds, the system must either pause safely or route to an alternate approver. Otherwise, the agent becomes a nagging bot, and humans root around it and governance collapses. This is the operating model: clear ownership, tiered lanes, explicit evidence standards, continuous drift detection, and enforced escalation. And once you have that, trust stops being an argument about whether Copilot is good. Trust becomes a property of the architecture, which is the only kind of trust an enterprise can defend in an audit. Case study: industrial manufacturing reframed as context redesign. Take a global industrial manufacturing organization with a familiar symptom. Average issue resolution sat at 72 hours. Not because the engineers were slow, because the enterprise ran the workflow through human memory, email archaeology, and Teams thread roulette. A line went down. Someone opened a ticket. Then the real work started. Who owns this system? What changed? What was the last approved configuration? Which vendor is on the hook? What did we decide the last time this happened? None of that lived in one place. It lived in people, in inboxes, in a spreadsheet someone trusted until they retired. Leadership saw this and concluded they needed AI for faster troubleshooting. And they were wrong. They needed context architecture, so troubleshooting had a substrate to stand on. The intervention wasn't framed as deploy Copilot. It was framed as unify identity context, engineer organizational memory, track operational state, then add a learning loop. Only after that do you add an interaction surface. Start with identity and memory. Entra plus graph. The organization didn't have a single reliable mapping between a production line incident and the humans, systems, documents, and prior decisions that mattered. Graph already contained signals, maintenance meetings, shift handover notes, files, work orders attached to emails, recurring Teams chats, and the real social structure of who asks who when the line is down. But those signals were not being treated as an engineered asset. So the first redesign move was to collapse the scattered work artifacts into governed containers with stable ownership, and then let Graph reflect reality with fewer broken edges, fewer orphaned sites, fewer everyone has access groups, fewer random shares that made retrieval noisy and dangerous. And then they treated permissions like a compiler. They ran permission trimming specifically for the incident response domain, reduce overshared libraries, fix inheritance where it had drifted, and eliminate the classic pattern where a broad operational group had read access to everything, just in case. That single decision did two things at once: reduced AI oversharing risk and improved groundedness by reducing eligible noise. Next, operational state in Dataverse. Before Dataverse, state lived in a ticketing system plus human coordination. The ticket told you a status. It didn't tell you the real truth: which approvals were granted, which exception was active, which vendor response was pending, which workaround was authorized, and who was accountable right now. So they built a simple state contract, not a giant transformation program. A state model with the minimum entities required to stop the loop: incident, impacted asset, owner, current step, SLA, approval gates, exceptions, and escalation path. Now the workflow could be replayed deterministically. The system didn't need to infer whether an approval happened. It could check. It didn't need to guess who owned the next step. It could read it. And when the workflow hit a refusal condition, missing evidence, conflicting procedure versions, or an action that required a human signature, the system escalated instead of improvising. Then, analytical memory in Fabric. They captured the signals the business never had. Time spent in each workflow state, which steps produced the most exceptions, which incidents reopened, which evidence sources were repeatedly retrieved but never cited, and where the same problem reappeared with different labels. Fabric didn't optimize the plant. It exposed where the organization was lying to itself. It showed, for example, that certain approvals were pure theater, always granted, always late, and always the bottleneck. It showed that a specific set of procedures caused delays because they were stale, contradicted by newer practices, and still socially dominant. Those insights fed back into the relevance windows and governance. Old procedures became ineligible by default. Ownership got assigned, review dates became real. The system stopped treating archives as decision-grade evidence. Only after all of that did Copilot enter the narrative. Copilot's role was deliberately constrained: synthesis, recommendation, evidence assembly, and escalation prompts. Not final decisions, not autonomous actions on production systems. The interaction layer served the humans supervising the flow, not the other way around. The result was not better answers. It was fewer loops. Average resolution time dropped from 72 hours to 28. Coordination threads dropped by roughly 40% because people stopped re-asking basic state questions. Duplicated workflows dropped by about 30% because the system could see existing cases and their status. And audit preparation time was cut in half because provenance and state were already recorded as part of normal execution, not reconstructed during panic week. The outcome wasn't a smarter enterprise. It was a less ambiguous one. Autonomy didn't remove humans. It moved them up the stack, from context reconstruction to context supervision. What leaders get wrong when they scale Copilot? Leaders usually don't fail at scaling Copilot because they lack ambition. They fail because they scale the visible layer and ignore the substrate that makes it behave. The first mistake is treating licensing as strategy. Procurement loves this mistake. It feels decisive: buy more seats, watch usage climb, declare momentum. But licensing only changes who can ask questions. It doesn't change whether the tenant can answer them with evidence, with permission correctness, and with stable definitions. So leaders end up measuring adoption while the organization quietly trains itself to work around the system. Copilot's fine for drafts, but don't trust it. That's not success. That's normalized distrust with a renewal. The second mistake is treating prompt training as the primary lever. Prompting looks like leverage because it's immediate. Run workshops, publish templates, share top prompts for managers. And yes, it helps people communicate intent, but it doesn't fix context fragmentation. It doesn't fix stale procedures. It doesn't fix overshared libraries. It doesn't fix broken inheritance. It doesn't fix the fact that half the organization stores decision-grade work in personal OneDrive with ambiguous naming. So prompt programs become a mask. The enterprise gets slightly better at asking for answers. It does not get better at making those answers defensible. The third mistake is scaling agents before scoping tools. Executives hear agent and assume automation, then ask why the organization isn't using it for approvals, onboarding, procurement, incident response, and customer comms. And the problem is that tool access is where autonomy becomes liability. If an agent can read broadly and act broadly, you've built a high-speed pathway from retrieval mistakes to real-world consequences. The enterprise then reacts the way it always reacts. It adds exceptions, entropy generators. This one team needs broad access. This workflow can bypass the approval in emergencies. This connector is fine because the vendor is trusted. Over time, the autonomy layer becomes conditional chaos. Lots of rules, no enforceable intent, and an execution surface that's impossible to audit. The fourth mistake is ignoring oversharing until it becomes a headline. Most Copilot security incidents are not Copilot incidents. They're permission reality made observable. Copilot simply retrieves what the user can already access. That's the design. So when leadership discovers Copilot surfaced something embarrassing, they tend to blame the assistant instead of the access model. Then they overcorrect, block features, disable web grounding everywhere, restrict everything indiscriminately, and kill value for the teams that could safely use it. The stable move is boring: permission hygiene and relevance scoping. Reduce eligibility, raise authority, make fewer things retrievable by default, not because secrecy is good, but because noise is dangerous. The fifth mistake is using the wrong success metrics. Number of chats is not a business metric. Neither is hours saved reported through self-assessment surveys. Those are adoption signals. They're not integrity signals. If leaders want to scale Copilot into autonomy, the metrics have to shift to system behavior: reduction in rework, fewer approval loops, lower exception rates, fewer duplicated workflows, shorter cycle times, and, quietly the most important, fewer permission faults discovered in the act of using the system. When those move, value is real because the enterprise is less ambiguous, not because the assistant is more charming. And there's one mistake that sits under all the others. Leaders assume scaling is a rollout problem. It isn't. Scaling is an architecture problem. It's about whether the organization can keep intent stable as the environment shifts, whether it can maintain freshness rules, whether it can version evidence standards, whether it can detect drift, whether it can enforce refusal conditions when evidence is missing, because if the system can't refuse, it will guess. And in an enterprise, guessing doesn't just create wrong answers. It creates wrong actions, wrong approvals, and wrong records that live forever. So when a leader says we want to scale Copilot, the only responsible response is to translate that into an architectural commitment: scale memory quality, scale state discipline, scale learning loops, scale control planes. Copilot scales naturally after that. Before that, it scales confusion faster than it scales work. The 7-day context inventory. So here's the part leaders usually skip because it feels unglamorous. A context inventory. Not a data inventory, not a we have SharePoint inventory, a context inventory. Where does the enterprise actually store identity, evidence, state, and learning in a way an agent can use without guessing? And it has to be a 7-day exercise for one reason. If you can't get clarity in a week, you're not doing architecture. You're doing therapy. You're collecting opinions until the calendar saves you from making decisions. This inventory has one goal: expose the top 3 context breaks where work loses continuity, where it drops state, loses authority, or loses control. Those breaks are where Copilot looks random. Those breaks are also where agents become dangerous. Start with the first question: where does identity context live? Not we use Entra. Everyone uses Entra. Identity context means where is the current enforceable truth of who can do what from an access and risk posture perspective. Which groups actually govern access to decision-grade content? Which conditional access policies define the boundary conditions for sensitive workflows? Which roles exist in name only? Which users carry historic privilege they no longer need? And which non-human identities, apps, service principals, connectors have permissions that nobody can justify anymore? If you can't name the owner of your authorization model per workflow domain, you don't have identity context. You have a directory and a pile of entitlements. Second question: where is workflow state tracked? Not in tickets. Ticket status is not state. It's a label. State means the contract that proves the workflow's reality. Approvals, exceptions, ownership, SLA, gates, and refusal conditions. If a critical workflow can't answer what step are we in, who owns it, and what is allowed next without reading a Teams thread, you don't have state. You have coordination, and coordination can't be automated safely. Third question: where does historical intelligence live? This is where organizations fool themselves with storage. Historical intelligence isn't "we have archives." It's, do you have an analytical layer that can tell you what keeps repeating, what keeps stalling, and what keeps generating exceptions? Can you quantify rework and permission faults? Can you see where evidence conflicts and where policy drift creates ambiguity? And can you feed those signals back into governance, or do they die as dashboards that nobody trusts? If you can't answer that, you don't have learning. You have telemetry exhaust. Fourth question: where are permissions actually enforced? This sounds like identity again. It isn't. Permissions enforcement means where is the boundary that Copilot and agents will inherit, and is it coherent? Which SharePoint sites are overshared where inheritance is broken? Which teams have guests and external sharing but store decision-grade content? Which containers have no owner? Which content lacks labels, so DLP can't act? In other words, where's the tenant porous, and are you pretending it's fine because nobody complained yet? Because Copilot will complain for you, publicly, in a meeting. Fifth question: where is your signal telemetry centralized? If the organization can't observe behavior, it can't govern drift. You need to know what evidence sources get retrieved most, where citations fail, where refusal conditions trigger, which workflows escalate constantly, which identities experience CAE revocations mid-run, and where tool invocation patterns look abnormal. That's not AI monitoring. That's the control feedback required to run a probabilistic system without lying to yourself. Now, the deliverable from the 7-day inventory is not a report. It's 3 decisions. Decision 1, map owners. For each context domain, memory, state, learning, interaction, assign a named owner with authority to enforce standards. Not a steering committee, a person. If you can't assign an owner, you've learned the most important truth. Autonomy will collapse into exception handling because nobody can enforce intent. Decision 2, identify the top 3 context breaks. These are the points where work loses its spine. Common examples: approvals tracked in email only, policy stored in ungoverned wikis, incident artifacts scattered across personal drives, vendor onboarding living in spreadsheets, or sensitive content stored in Teams with guest access because it's easier. Write them down, don't debate them. Context breaks aren't philosophical, they're observable. Decision 3, pick one workflow for a 30-day pilot. 1. Not enterprise-wide, not all knowledge work. One workflow with visible pane and manageable blast radius where you can implement the 4 layers: graph memory, Dataverse state, fabric learning, Copilot interaction with explicit refusal conditions. If leadership can't choose one workflow, they're not blocked by technology, they're blocked by accountability. And that's what the 7-day context inventory really does. It forces the enterprise to admit where reality lives, where it doesn't, and where the system will be forced to guess. Because once you see where guessing happens, the architecture stops being abstract. It becomes unavoidable. The 30-day pilot pattern. 1 workflow, 4 layers, enforced assumptions. Pick one workflow where failure is visible, frequent, and expensive. Approvals, incident response, onboarding, procurement. Anything with handoffs, delays, and a paper trail you can't reliably reconstruct without begging 3 inbox owners for screenshots. Then do the one thing enterprises avoid: define the assumptions up front and make the system enforce them. Because the pilot isn't about proving Copilot works. Copilot always works. It produces words on demand. The pilot is about proving your context substrate can support evidence-bound decisions without improvisation. Start by defining the workflow boundary in plain language, what triggers it, what done means, and what irreversible actions exist inside it. If done isn't defined, the agent will keep acting until someone stops it. That's not autonomy, that's entropy with good grammar. Now implement the 4 layers, but keep them deliberately small. First, graph memory. This is where you stop treating M365 as file storage and start treating it as organizational recall. Choose the authoritative containers for the workflow, the SharePoint site, the Teams channel, the policy library, the decision log. Then fix the obvious garbage, broken inheritance, abandoned owners, and the everyone group that turns retrieval into noise. Don't boil the ocean, just make one domain coherent enough that retrieval can be precise. Second, Dataverse state. Create the minimum state machine that prevents relitigating work. Request record, status, owner, SLA, approver, exception flag, and a small set of explicit transitions. The point isn't to model reality perfectly. It's to give the system a place to store truth that isn't buried in narrative. When the agent asks, has this been approved, it should query state, not guess based on tone in a Teams message. Third, fabric learning. Instrument the workflow from day one. Track cycle time per state, number of escalations, number of retries, evidence coverage, and the top reasons for refusal. You're not building a dashboard for leadership theater. You're building a feedback loop that tells you where context broke. Missing sources, conflicting sources, permission faults, or state transitions nobody owns. Fourth, Copilot interaction. Put Copilot where humans already work and constrain its role. It should assemble evidence, summarize state, draft responses, propose next steps, and generate the audit narrative. It should not execute irreversible actions. It should not decide policy. And it should not have silent tool access that can change systems without a gate. Now the critical part, enforced assumptions. Define refusal conditions like you mean it. If required evidence isn't found in the authoritative container, the system escalates. If the user's permission posture is inconsistent, the system refuses. If the request crosses an external boundary, the system requires confirmation. If the workflow state is ambiguous, the system asks a single targeted question, then writes the answer back to Dataverse, so it never asks again. This is where you learn whether you have an autonomy problem or an accountability problem. Because refusal conditions force ownership, someone has to decide what counts as evidence, what counts as stale, and who approves exceptions. Without that, the pilot becomes another demo environment where the only reason it works is because smart people babysat it, measure 4 things for 30 days, and ignore the rest. Cycle time. Did it actually get faster, end to end, not just in drafting email? Rework. Did people stop repeating the same steps, the same approvals, the same clarifications? Exception rate. Did the system have to escalate constantly because the process is undefined or because the context is dirty? Permission faults. How often did retrieval fail because access is wrong? And how often did retrieval succeed because access is dangerously broad? If those metrics improve, you don't just have a successful pilot, you have a repeatable pattern. Then you clone it, not by copying flows, by copying architecture. The same 4 layers, the same boundary discipline, the same refusal mechanics, the same telemetry loop, and the same ownership model. That's how you scale without turning autonomy into a tenant-wide rumor. AI won't transform your enterprise. Context architecture will, because it forces probabilistic outputs to stay bound to evidence, state, and control. If this landed, leave a review for M365 FM, connect with Mirko Peters on LinkedIn, and message the one context break you want dissected next. Copilot, graph, governance, or agents.